Well, hello everyone, and welcome to Digital++. This first series is about building a metaverse. Well, in this series I will build a basic but fully functional multiplayer VR application in Unity. There will be a part 1 and a part 2 with a total length of about 60 minutes. If you decide to code along, by the end of part 2, you'll have a fully functional baseline VR application that you can use for any multiplayer VR game, or even build your own part of the metaverse. This application will be vendor agnostic, so you can run it on any VR system that is supported by Unity. Now, let's roll up our sleeves and get into the weeds. What do you need to know to be able to follow this series? The very basics of Unity. You should know the basics of scripting, C#, in particular in Unity, and you would need to have some understanding of networking and how do IP addresses work, etc. During the videos, I'll try to explain the why. For the code monkeys amongst us, we will go into the details, but before we start coding, I really want to discuss some basic design. So let's start with some R&D. Let's quickly look around what's available and how do we want to build this thing. So we want our application to be platform agnostic. That means we don't want to be limited to any vendor or technology. On the other hand, we know that historically building 3D and VR applications can be really complicated, right? So we want to use a development platform versus coding from scratch. The most common one is Unity. So our selected platform for this series will be Unity. We want to be XR vendor agnostic. Within Unity, there's libraries from Oculus, from Pico, from other vendors. So we'll use the openXR plugin in Unity. Once you are able to run your application on openXR, you'll be able to run it on multiple devices. So if you move your hands, you want to see your hands move in virtual reality in the same way in exactly the same position. And therefore you would need a so-called XR hands package, and also an XR interaction toolkit, which allows you to use your controllers in your hands in virtual reality. And a great advantage of this XR hands package and the XR interaction toolkit is that there's a fully prepared XR rig prefab available. It automatically switches between controllers and hands. Saves a lot of time building animations. We want our application to be multiplayer. So Unity has a solution called NetCode for game objects that is used to build multiplayer applications. And there's other platforms available which are called Photon Fusion, formerly known as BaM. There's also a platform called Coherence, and there's other ones as well available. But the decision here is to stay with Unity NetCode for game objects because it's for free and it's default included in the Unity environment. Important to understand that multiplayer applications need the internet, and to be able to run properly, you will also need a hosted server or service. So for NetCode, this is called relay services. But during development, we don't need that. We can use our PC in host mode. So once we've done the research, we know where we want to build this thing from, we need a little bit of a design. I won't overdo it here, but a few things we need to know before we really can get started. So we need some kind of a user interface to interact with and to debug. So the annoying thing about virtual reality glasses is, once they run standalone, you don't really see if there's any errors generated, right? Because you're just basically in your VR space, and there's no way you get a heads up on any debug console, which is so very convenient in the Unity environment. Also, you need some buttons, etc., that you can click to, for example, start a host or start a client connection to your environment. At the beginning, we can build a very simple avatar to start testing XR interaction. And so you want to track your head movement, you want to track your hand movement. So the last part here is about networking. So there's a couple of ways you could design networking. A couple of folks who have followed this approach, which you show here as I call option 1. So if you look at the middle, there's a network, and then all of your XR devices have an object in Unity that somehow then need to communicate to each other. So what you do is you put all the effort in making sure that these objects are replicated over the internet. So on the other side, all the other clients and the remote participants know how your hands are moving, how your head's moving. The avatar that represents you on the other side actually follows your same movements. There's another way to do it, which I find is a more preferred solution, is let's keep away all of the XR rig mechanics from the network because it's very complicated, right? Switching from hands to controllers, etc. That's a lot of code. And opening up that to the internet, that also means you need to do a lot of logic to make sure that you don't open up too much. So I think now it's time to get our sleeves rolled up and really start building. So let's get started. Let's open up Unity Hub. So I have installed 2021.3 and I've installed 2022.3. And 2022.3 still has an issue with one of the crucial prefabs that we want to use. So I recommend to not use that at the moment. Make sure when you install your editor that it supports Android. In this case, I also support Windows. But the most important thing is that you have Android installed with all the SDKs and JDKs. So when you install editor, you can say, well, there's a new one available here. So if you do install, you can identify, okay, I need to have OpenJDK and OpenSDK. So make sure that these checkboxes are all set. I won't install them now. So I'm going to use 2021.3 for a new project. So let's go back to projects, type new project. We go for the 3D URP because it provides some templates and tools, etc. And the integration with the editor is really managed well. So we'll call this BaM test. We create the project with the right version. So click on top here and select 2021.3. We'll click on create project. I'll pause for a second because it'll take a couple of minutes and then we'll carry on once the installation is complete. It's been installed. Let's do a quick run, see if there's an error somewhere. No, it all works perfectly. Okay, great. So the first step that we're going to do is we are going to install openXR. So we go to Window, we go to Package Manager. Here you go, Package Manager. And then you start typing here XR. And obviously we need to select the Unity registry, not in the local project. So there we go. Let's go with XR. So we will start with the openXR plugin and not the Oculus XR plugin. Because we want to, if you remember, our application should be vendor agnostic. Okay, so there's warnings. So we'll want to restart the editor. Yes, because there's a new input system. Okay. Let's close the package manager. So now we need to configure the XR plugin. So we go to Edit, Project Settings, and we go to the XR plugin management. Select openXR. There's a warning here, so click on that. It will give you a message that there are some issues, so we'll try to fix this. And this one we can edit. All right. So at this point in time, you need to have at least one interaction profile. So the list is empty. What we'll do here is we click on the plus and we'll see Oculus Touch controller profile. You can add whatever you want. For now, I'm just going to add the Oculus Touch interaction profile. We'll do that in the Windows tab. We'll do the same in the Android tab. So there's two tabs here, Windows, the Android tab. Android tab is the one that will be loaded on your dedicated virtual reality device that you have. Most of these devices run Android. So that's why you need to have the Android integration separately configured. And let's go back to XR plugin management. So we have openXR here. We'll do the same for Android. We'll need to do openXR. And hopefully by now the warning message should be gone. There's no more warnings. Great. So that is all done. So now we want to go install the XR interaction toolkit. So we go back to the package manager, Windows package manager, again, type XR, and we'll have the XR interaction toolkit. We'll click install. You should have a version that's at least above 2.3.0. I made a backup, go ahead, and there we go, we have it installed. Now important here as well that we go and click on samples, and we want to have the starter assets, right? So we'll import these. And we want to have the hand interaction demo. That contains a fully pre-configured prefab for your hands so that in virtual reality you can actually see your own hands and everything moves automatically with it. So those are important to have. So I'm going back to Edit, Project Settings, and now we have the XR Interaction Toolkit, right? And there's a warning signal here, so click on that, please. You'll get the following message. It says Interaction Toolkit, layer 31 is not set to teleport, so fix that. Otherwise, you continue to have annoying messages. So that's done. So I'm clicking on product validation, and I'm seeing some issue. So I need to install that thing, so that's done. There's another here again for Android, so let's click on fix that too. There we go, all done. Here we want to click the Meta Quest support. So they want to have under openXR the hand tracking system selected, the Meta hand tracking aim selected, and the Meta Quest support selected for Android. And we'll have the same for Windows. These two clear. So let's have a look, and we can close this window. So next step is going to Assets Samples, XR Interaction Toolkit 232, Hand Interaction Demo, Runtime, Prefabs. There's a prefab here which is called Complete XR Origin Hands Setup. Well, this is a very crucial prefab that we are going to use, which will provide you with all the automatic mechanisms and scripts to automatically switch from your controllers to your hands. So we'll drop it into our scene, and then what we'll do as well for now is that we'll go to the prefab and we'll unpack it completely because we'll want to make some changes. That's done. We can now start testing for the first time and see if it does work. One way to test is with your Oculus Link. So I have my Oculus Quest here with a link cable, which is a USB 3.0 cable. You'll need to have Oculus Link installed. So this is the Oculus Link app that I have. You see here, it's all green and it shows me that the device is active and visible to the system. Again, if you have another device, you'll have something very similar. Another way you can test is to go with File, Build Settings, and then in Build Settings, you can do Build and Run. And what you do, if your target platform is the Android tab, obviously, and then you switch platform, so it'll take a while, and you switch it there, that you will compile the application already for your Android. Okay, so now we've switched to Android, which means we can now start building a dedicated application that will be loaded onto your glasses, and you can basically pull the cable off and run the application standalone on your Oculus Quest or your Pico or whatever. The first thing we'll need to do is add open scenes and make sure that the scene that we just created is installed, and then you can click build and run. There's one more thing we need to check, and that is if we go to project settings again on plugin management, you will see an exclamation mark next to openXR. Click that, and there's a warning here that only ARM64 is supported on Android, so we'll fix that. We will need to remove the main camera because the XR device here already has a camera. You can't have two cameras in a scene, right? So we'll remove that. And then we'll also add a 3D plane that you can walk around on. So we'll go to 3D object, we'll go to plane, and we will scale it to 10, 10, 10. We will also create a new material. So let's go to assets, and then we'll add material. We'll call it plane material. Yep. And the color will make that nice gray. There you go. And we'll make it a little bit metallic and shiny. There we go. So the plane, the mesh render materials, and we'll drop the plane material there. So now it is gray. Now let's have a look and see if we can now run our application. And there we go. So if you look at, I see my controllers, my right controller, I see my left controllers. There is an array that I can interact with in the future, so we'll use that. And when I put my controllers down and I go to my hands, you will now see it'll automatically switch and my hands will be available, and they will actually follow all my movements. So I can wave with my left hand, with my right hand. Yeah, this is all pre-configured and it's very convenient and handy, but you can't move around yet. So let's start building a couple of things to be able to move around and create some more interaction. To continue, we will do a little bit of maintenance and housekeeping. I usually create a number of folders and we'll call them materials. We will create a folder and we call that scripts. And we will create another folder called prefabs. So those are the ones that will be really useful for now, and then we can nicely organize it. So let's drop the plane material in the materials folder. So we got it all clearly organized. Okay, so we'll add some movement to the XR rig now, and we'll do that by the following way. So we'll go to the complete XR origin hands setup and into the XR origin, and we're going to add a couple of components to allow us to move around. So the first thing we'll type here is locomotion system that will allow you to move around. Now drag drop your XR origin into the XR origin field. Another way to do it is click here and select XR origin. Two ways to do the same. And then you want to start adding two more components, which is continuous move provider, action based. And we'll add another one, continuous turn provider, action based. So the continuous move provider will allow you to move around with your joystick of one of your controllers. The continuous turn provider will allow you to, well, guess what, turn around also with one of your controllers. The locomotion system here is our XR origin, and we'll do here the same on the system, XR origin, the forward source in your continuous move provider. So that'll be your main camera. So select that here. So we want to configure our left controller to allow us to move around in virtual space, and we'll use the joystick on that. So we'll say use reference, and for your left hand move action, keep the right hand move action empty, and we will select XRI left hand locomotion move. So double click that, and that is configured. So now the left hand will actually allow us to move around. Let's go to the right controller. With the joystick, we want to do the same. With the joystick in the controller, we want to be able to turn. So now on the right hand turn action here, we click use reference, and we scroll down and we go to the XRI right hand locomotion / turn. Double click that. And now let's start and run our application, see if we can actually move and turn around. There we go. So you see my controllers here, but you can actually see on the horizon that the horizon of the plane is moving, and we're now moving around. We look at the sun, so that's great. And we can actually start moving forwards and backwards. Within a few clicks, we've allowed ourselves to create controllers. We have hands, and we can now move around in virtual space. Let's do a little bit more interaction now and start building a user interface. All right, the first thing we'll add is canvas. So we go to UI and add a canvas. By default, the render mode says screen space overlay, but that will not work in a VR device. So we'll have to go to world space. Once that's enabled, you actually can change the position. So we'll locate it now and we'll move it to position 15, 10, 20. That's something I just figured out by doing testing. The width of 20 and a height of 20. And then the scale, I make it a bit smaller, 0.5.05. We'll move the main camera into the event camera, otherwise you get a warning message. And now we'll add a child object, so create empty child, and we call it launch UI. This is actually a script. We'll add that a bit later. So we can add here is launch UI. That's a new script, and we'll give it enter. There we go. And then we will add a 3D object, and it is called a text from TextMesh Pro. Obviously, we don't have TextMesh Pro installed yet. You will have a message, so please import TMP Essentials. That will allow you to create buttons with text on it. Sample text. I'll remove that. Then in the launch UI, we create a new child object UI and button TextMesh Pro. There you go. So we already see the button now appearing, and we will name that host. And to change the text, because you'll see the text of the host button isn't changed yet. In the button, there's a text TMP, so you can click on that, right? So host text, and you change the text from button to host. And there we go. Right. So what we want to do now is copy, paste that, Ctrl+C, Ctrl+V. We'll call this client. So this will be a client button, and open the text underneath and change that into client. We'll have the client button a little bit down. To make sure that you interact with the buttons, so go to the launch UI add a tracked device graphic raycaster. That will allow us to interact directly with the UI. We'll move the host under the launch UI and the client under the launch UI object. And we'll, for host, the host button, we'll add a tracked device graphic raycaster. And for the client button, we'll do the same. So add component and track device graphic raycaster. So we'll now add a little bit of code to a function called launch UI. So what we want to do is when we start the application, there will be two buttons here, right? One to act as a host, one to act as a client, and that will implement the code for that later. If you want to have a multiplayer environment, you should select whether you are going to be the host or whether you are going to join an existing server. And so the details will come later, but we'll prepare for a little bit of that code already now as we're working on the UI. So double click here on the launch UI script. It'll open Visual Studio 2019. We'll remove the start and the update function because we won't need that. Serialize field, and we will call that private button, host button. It will not recognize button, so right click here, show potential fixes, and it says using Unity engine.ui, right? So then now you have imported the libraries and it will know what buttons are. And we can do the same here. We can copy paste that, and we will do a serialize field ahead of that as well. And we'll call it client button. So with that, what we're doing is we are making sure that these two button fields are going to become available in the Unity user interface, which I'll show you in a second. So now we need to have a new function which we will call private void awake, and we will create, I'll do this quickly with copy paste, two empty listeners. Add code here. We'll do that later on once we start implementing the network, but for now it would be just nice to have the code here. So now let's save this thing and minimize it. It'll reload the file, and then if you remember, we created two serialized fields, one for host button, one for client button, and they now show up here. So what we'll do, we'll take the host button here and we'll drag drop it into the host button, and we'll create a client link as well by dragging dropping the client button link to this field. So that is that. Now, if it's very difficult to test anything if you don't have a debug log in your UI, specifically if you're in virtual reality, and it'll be very difficult to identify errors and issues. So what we'll do is we'll add a third-party product called the in-game debug console, and we'll add the console into our UI so that we can record and see any error messages while we are working on the implementation of this application. So we'll go to Window, Package Manager, and in this case, we will start looking into My Assets. And there's an in-game debug console. I'll provide the link to the asset store where you can actually get this package. It's not available in the Unity registry. If you go into My Assets and you purchase it, and it's for free, by the way, you can now install it. So let's import it. Import the whole thing. Plugins, impact theme. There you go. So it should show up under your plugins. There's the in-game debug console. Take the prefab and drag drop it into your canvas. There we go. There's an event system in there, and it should be turned off because we'll have already one event system here in our XR hand setup. We can't have two event systems. And what you want to add here as well, very similar to the buttons, you need to have your track device graphic raycaster so you can interact with the device. There's one setting here that you will need to change. Start in pop-up mode. Turn that off. When you start your application, you will see the debug log and not a minimized version of it. One thing we need to change here is the location of this thing and the size. So the position, we set it to -675. The Y position should be -150. Position Z should be 0. The width should be 1000 and the height should be 400. Okay, and then a scale of 0.5, 0.5, 0.5. Now let's run and see if we have a debug window. There you go. So you'll see I have my debug window. If there's any issues or messages, you could see those here. I can't click on anything yet, so I'm clicking here on host client on any of the buttons and it's not working yet. So we should obviously fix that first. We want to be able to influence and click on things with our left hand, our right hand, left controller, right controller. So on your left controller and your right controller, start with those. You have predefined poke interactors, which help you with manually poking buttons. We won't do that for now. You have direct interactors, which allow you to pick up things and move them around. And you have ray interactors, and that's the one we want to use for our user interface. On the ray interactor, we do want to maximum raycast distance. By default, it's 10. Let's change that to 50. We'll do the same for the right controller, 50. And we'll do the same for the right and the left hand. So the right hand, we'll make that 50. And the ray interactor for your left hand, we'll make that 50 again. And now let's see if that works. You see if you move over, it starts to become blue, so the interaction is working. I can actually minimize and maximize it. If there would be messages, I could start selecting them here. For some reason, my buttons aren't working yet, so let's have a look on why that's not working. And on the client button, we'll need to add the graphic raycaster as well. So let's run and see whether it works. So there you go. Now when I move over the client and the host button, I can click them and you see that nothing is moving yet. So let's see if our debug window works, right? So if you remember, we have our launch UI script, so we can open that and let's click that. And let's see if we click on the host button, we can start typing debug.log. I clicked the host button, and let's do the same for the client button. Debug.log. I click the client button. And I will start again and we'll run. Okay, so let's click on the host button and I click the host button, and let's click on the client button. I click the client button. So that works for both controllers. Let's see if the hands do the same. And we'll go over there. You see it gets blue. I click on it. I click the host button. With the left hand, I click the client button. And if you want to minimize that because it's in the way, you can minimize it. You can open it again with both your hands and your controllers. If you look at this properly, look at our debug log here. There's an error message. Couldn't find active control after binding resolution. When I put down my controllers and I switch to my hand, you see the error message appearing. This is the bug that's in the fully pre-configured prefab, which prevents the Unity 2022 version to not work. So when you do this same as we've done so far in the 2022 version, your controllers will never come back. You'll see your hands, but your controllers will never pop up again. So that's the reason for now where we're still on 2021. So let's do a quick recap. We have created our project. We have created a XR environment. It's an openXR environment. We've created a user interface. So our next topic that we'll look into will be creating a very simple avatar. Okay, so that wraps it up for part number 1. In part 2, we will build a ridiculously simple avatar. We'll implement NetCode for game objects, and we'll look at the best ways to test your VR applications. I really hope you enjoyed this video, and if you did, please like or subscribe to my channel. Also, feel free to post any questions. I'll be more than happy to help where I can. See you back in part number 2.